Good morning, everyone. Today we are discuss about 8086 microprocessors architectures. So, so we are discuss about the two parts of the architecture. Basically, it's two parts of the architecture. First one is bus interface unit, and the second one is execution unit. In the bus interface unit, is only fetch the instruction, not the execute them. But whatever the fetch the instruction will pass to the crew bus to the internal control system to the ALU, which will here arithmetic logical unit is used for the run or execute the instruction. It is located in a execution unit. Execution unit is instructions that have already been fetched by the bus interface unit, and this is used for execute the instruction. So we have first talk about the bus interface unit. In the bus interface unit, there are 16-bit register like the code segment, data segment, source segment, execution segment, and internet protocol and internal communication register. All have 16-bit, and here is address generator. We have gives the address of the instruction. So the internal protocol has 16-bit and code segment has 4-bit. Combined with both bit and create the address bus of 20-bit. You passes through the bus control logic, which is 8086 bus, and it passes through the all instruction in queue bus of 66-bit, like first, second, third, fourth. What is that mean? First is first instruction, which will fetch by the address generation, then after second bit, then after third bit. What does use that mean? The first instruction pass to the internal control system and execute an ALU. Then after suddenly two is become ones, and after the first execution, second will become a second will go to the internal control system and ALU in an ALU and execute them. So time complexity is lower because of Q bus system. In the in execution unit, we have flag register, temporary register, and internal control system, and arithmetic logical unit, and general register. General register has 16 bit. All register has 16 bit, and AX, BX, CX, and DX are divided into 8 bit and 8 bit, like A higher and A lower. Okay. Then after we have seen individually of them, like bus interface unit have 4 register: code segment, data segment, stack segment, and extra segment. Here we already discussed about adder to generate a 20-bit segment register, and not used for code segment. What is the code segment? Here 16-bit code. CS is contains the base of the start of the current code segment, and IP contains the distance or offset from this address of the next instruction byte of the fetch. Bus interface units computes a 20-bit physical address by logical shifting in the content of the CS4 bits of the left and then adding the 16-bit contents of the IP. This is what is for code segment register. Then after data segment register, here the we can write in exam is first one common point. All register has 16-bit, and only for code segment and internet protocol we have write one add point, like the code segment of 4-bit and uh, internal protocol has 16-bit combined in an adder, which is located in address 4-bit. 16 plus 4 equal to 20-bit. Combine the 2 of bit and make a 20-bit queue bus. Data segment, stack segment, which instruction pass the which have all 16-bit point on the current bit of stacks, and all instructions such as a push, pop will fetch here. Extra segment is like the point to extra segment is which data of 16K point to the by the DS installed, and steering instruction use the ES and DI is determine the 20 bit of physical address of destination. Instruction pointer, we have discussed already about this point. And what is the instruction queue? We have already discussed about this point, like everyone. Instruction queue meaning that the 6 byte of the instruction first will first in first instruction pass to ALU, then execute this instruction, and suddenly 2 becomes 1, and the next instruction is 2. What the instruction unit work? Then we have discussed about the execution unit. Execution unit is uses for execute the instruction and translate the instruction. 16-bit ALU's bit is 16-bit for the performing arithmetic and logical operation. And general register like AX, BX, CX, and DX. Oh, 1 minute. Okay. For general register purpose like AX, BX, CX, and DX, pointer register and index register of each 16-bit. Already discussed about AX can use for A higher and A lower. Accumulator register. What is used for accumulator register? Consists of the 2-bit, 8-bit of register A lower and 8-bit register of A higher. A lower is in case contain the low order of byte of the word, and A higher is the high order of the byte. Um, in examination, whenever we write about the execution unit register AX, BX, CX, and DX, we have we have one common point in every register, like accumulator register. So accumulator register have two register, a higher and a lower. Both register are 8 bit each. We have write about same as base register, coda, counter register, and counter register instructions such as shift, rotate, and loop used of the CX counter, and data register also. And what is the stack pointer and what the use of the stack pointer? So stack pointer is basically used for offset from the current access of the execution in the instruction will be involved in a stack segment in external memory. Stack pointer contents are automatically updated to the execution of the pop and push operation or instruction, sorry. Source index and destination index. Use source index and destination index used in a index addressing instruction that process data string. Use the source index and data index register together with data segment and execution segment uh, extra segment respectively in order the discussed between the source and destination address. What is the flag register? In the architecture we have seen in below the ALU unit we have one register in architecture which is flag register. So what does that mean? Here the 16-bit representation of the flag register. Here 1, 2, 3, 4, 5, 6, 7, 8, and 9 flags which is located in a flag register. Like first is carry flag. So what is in carry flag? Carry flag is MSD case for the borrow the case of subtraction. Second is parity. We have parity. We have learned about parity in the last semester. Or whenever output of the instruction will all becomes one, then have we can say have parity. Third one is auxiliary carry. Whenever we perform like the addition and borrow subtraction, which the lowest nibble in our carry generator, we have the auxiliary carry flag. Third one is zero flag. Whenever output of the instruction is zero, then we can say have flag. This flag is set because of zero output. To sign flag whenever bit representation, first bit representation F7 or the first bit is 1, then we have negative value that sign flag. Track flag. In the track flag is automatically generated internal interrupt after each instruction. Then we can have track flag. Direction flag. Direction flag is direction flag is used for the automatical and trick mode. Like all ones become zero and all zeros become one. Overflow flag is another used for the sign whenever the 15 bit is occupied. Then after we can have we can't add a 16 bit in this representation. And this is all about the microprocessor 8086 architecture. Thank you for watching the video.